So question 5 kind of summarizes this all up. Take a look. So the question is, you select one student at random from this group. Which of the following statements is true about the events walks to school and senior? We have two things going on here. We got mutually exclusive and then we have independent. So let's talk about the difference. Mutually exclusive events have no overlap. So in a table, if you're seeing mutually exclusive events, there would be no number in that category of the table. That'd be 0. In this case here, there are 40 students that are both in the senior category and the walk-in category. So they're not mutually exclusive. We have seniors that walk. They're not mutually exclusive because we have seniors that walk. But they are independent because these two probabilities are the same. So with independence, the probability of one happening would have to be the same as the probability of that happening given something else is affecting it. Does that make sense? So since the probability of walk is equal to the probability of walk given seniors, when they're equal, they're independent. Another way to think about that is you could get the probability of seniors is 88 out of 550. So you could do the overall, right? The probability of walking, that's probability of walking, not seniors. Let me do this on a separate page. So the probability of a senior is 250 out of 550, right? There are 250 seniors in 550. The probability of walking, that's 88 out of 550. Independent probabilities, if they're truly independent, when you multiply them, that's their overlap. So the probability of seniors times the probability of walking is 250 over 550 multiplied by 88 over 550. Let's take a moment to figure that out. So you can see it's about 0.0727272727 forever. Okay, so what does that mean? Well, look at the overlap. What's the probability of seniors and walking? So if you random select student, what's the probability that the person is a senior and walks? Well, that would be 40 out of 550. Okay. Check it out. It's the same percentage, 0.0727272727. So since we know they're truly independent, their products of those individual overall probabilities is equal to the overlap probability. We don't tend to go through all of that when we can just do this, right? We can just get one probability and do one given the other. And if they're the same, then we can say they're also independent that way too. But that's the math behind it.